In the last videos, we covered very clearly about the implementation of double linked list. So again, I'm going to revise for a few minutes. Just have a look once. Sir, what is the first thing here? We created double linked list class because the total concept I'm going to explain by using object oriented terminology. I'm going to create a class for double linked list. Whenever you need to create a list, we will create object for this double linked list. So if you want to represent a double linked list, compulsory you need to define one special structure called node. It can be holding data field and the next field called as a single node. So it can be double node also, having the data field and the previous field which is pointing to the previous node and the next field pointing to the next node. Like that, I created one node class which is having a constructor and having data field, next field, previous field. So if you are not giving any value for next field and previous field, the default values are nothing but none and then none. So first we are assigning the data value to data and the next pointer to next pointer, previous pointer to previous pointer. And coming to the double linked list class constructor, we are defining three attributes for this double linked list class. What is the first attribute? Head, which is always pointing to the none at very beginning. And the tail pointer is also always pointing to the none. And we have one special attribute is there called count, which is always pointing to 0. Like that we have. And there is one special function is there here. If you see size of the linked list, I'm going to return the size of the linked list. See, whenever we are adding a new element into the linked list, the count variable, already we defined that count attribute, right? That count variable will be incremented by 1 unit. For that purpose, I am going to take a special function called size, which is going to return how many number of elements are there. Okay, so next and after that, so even we have seen isEmpty method. What about isEmpty? It will return true if your linked list is empty. How to decide whether it is empty or not? If you take self dot count is equal to 0, then automatically your linked list is nothing but what? Empty. But when it is going to be happen at very beginning, okay, then yesterday I explained how to insert a new node at very beginning. So if you want to insert a node at very beginning, there are two cases are there. What is the first case? Still you didn't have any elements in the linked list. That means my linked list is empty. It is not having any nodes. In such cases, the node which you created will become head node and a tail node, and directly we are going to return. Suppose if list is already there, then whatever new node that you created, that will become sir head dot previous, and new node dot next field will become head. So then I'm going to replace that head position to the new node. How to insert at last? So if you want to insert at the beginning, we have head pointer, previous to that is nothing but new node. But if you want to insert at last, so tail node is there, right? So next to tail node will become that new node, but this case is very common. So like that we have seen. And how to insert the element at a specific location? In the specific location also, we have three cases are there. What is the first case? Suppose if you are giving index value as a 0, then what will happen? Sir, we are going to insert at the first location. If index value which you are giving is the last node, then we have to call that insert at last. Otherwise, we are taking two special pointers. So where you need to insert, before that one pointer will be there, after that one pointer will be there, so that you can attach totally how many links? 4 links we can able to attach. So this part we covered very clearly in the last sessions. Okay, sir, if you are clear with this, I will go through this print list function. How that print list function is going to work, I will demonstrate. Up to this, just I revised whatever we covered in the last sessions. Any doubts, friends, up to this? Sir, I need response from your side.
No, sir.
Right. So what is the next thing is, sir, I'm going to insert at first 40, insert at first 30, and just I need to call display function. Okay. So display function means better to take it as, so print function. Okay. Something like displaying the elements in linked list. For that, I am taking one function called print list. So always it is having the first parameter as a self. Now we have to display all the elements present in this linked list. To demonstrate this, consider I'm going to take one simple linked list for our reference purpose. So maybe assume I'm going to define only. So like this, we have total how many nodes are there? 3 nodes are there. Every node is associated with 3 fields. So this is nothing but which node? Head node. And this is nothing but which node? Tail node. Okay. Now, sir, head node content is 10 and this node content is 20 and this node content is 30. So head node next field is this one, 20 previous field is this one. 20 next field is 30, 30 previous field is 20. Next node is nothing but null, head node is nothing but null. Previous node, like this we have. Now we have to display each and every element. Sir, how to write code for that? Suppose if self dot head, if self dot head is double equal to none. If there is no head node, then what is the meaning? Can I say our double linked list? Our double linked list is empty. We can't able to display any elements. Simply come out from the function. Simply come out from the function. Otherwise, I'm going to take one temporary pointer which is always pointing to the head. After that, I will check is that a temporary node is not equal to none. If it is not equal to none, can you please print that temporary node data and sir, just maybe end is equal to some space I am giving. Okay. And temp will become, so temp will become, so temp dot next, like this I am going to take. That's all. At last, maybe to represent the last node, I am giving none and return the control. Sir, what is happening here? If you want, I will highlight with some other color, just have a look once. Sir, initially temp is equal to self dot head. Can I say this is nothing but a temporary node at the very beginning? Yes. Is a temporary node is not equal to none? Yes, because we have written inside a while loop, this will keep on running. Is a temporary node is not equal to none? Yes. Can you please print that temporary node data?
Sir, your
Is
voice is
nothing
not clear.
but a 10. Give some speed. 1 second, 1 second. Yeah, sir, now is it clear? Can you please confirm?
Yes, sir.
Right. Now you can see, sir, my temp is pointing to 10. So which is not equal to none. So it is printing the data. So after printing data, so what activity we are doing? We are taking temp is equal to temp dot next. Now my temporary node is pointing to 20. Sir, again, since it is a while loop, it will check is a temp is not equal to none. Yes. So it is going to print temp dot data. What is the data? 20. Now temp is equal to temp dot next. It will point to here. Sir, is a temp is not equal to none? Yes. Print the data, which is nothing but 30. So temp is equal to temp dot next. Have you observed? 30 next node is pointing to where? Null, none. Sir, is temp is not equal to none? No, temp is none. It will come out from this and it will print the last node is nothing but what? None, something like this. So this is nothing but the list of elements present in the linked list. Let us run up to this and cross check is it working properly or not. Sir, first I'm going to call, so list dot, can you please print the list? Since we have not inserted any elements as of now, so what output we are expecting? We are expecting the linked list as empty. Let us run py space dll.py. Double linked list is empty because no elements are there. Sir, list dot, can you please insert first? Okay, insert first of I am taking 10. So then list dot, so insert at last of 20 I am giving. So list dot, so insert last I am giving 30. If you print, what output we are getting? First we inserted 10, later 20 and then 30. Let me cross check, is it coming? Yes, 10, 20, 30 and then none. Sir, now after this print list, I want to add insert at first of 999. Now list dot print list I am calling. Is that 999 is added at beginning or not? We need to cross check. Now you can able to see, sir, it is added at beginning. Sir, in the place of this, insert first. So if I am taking insert at last, sir, what will happen? The node will be added at last. Is it added? Yes. Now I want to insert at a specific location. So I think, so insert at location function is there. So what is the first argument for that? First argument is index. Second argument is the data which you want to insert. I am taking 0, 999. Sir, is that value is added or not? We have to cross check. So let us run this program. You can see, sir, is that 999 got added at 0th location? Yes. Now I want to add at first location. Is it going to add at first location? Name none is not defined. Maybe there is a problem here in the insert at location. Somewhere the spelling mistake. Where, sir? Can you please see the line number? 69. Okay, 69. If you take the line number 69, temp is not equal to none n capital. That is the problem. Now you can see, sir, is it added at a first location? Yes. Now I want to add at a second location. Sir, is it going to add at second location? Yes. Now I want to add at third location. Something it is insertion at last. Now listen carefully. I want to insert at a fourth location. Have you observed what message we are giving? Array, your list contain only 3 elements. How you can able to add at a fourth position? Like that we are getting. Okay. So this is nothing but how we can able to perform insert at first, insert at last, insert at a specific location. And I am displaying all the elements at a time. Can you please confirm, is the concept is clear up to this?
Yes.
Right. Sir, now insert at first completed, insert at last finished, insert at location. Okay. Now we are going to talk about delete at first. Sir, I have a linked list is there. Okay. So insert at last function only I will take. So insert at last we have 10 is there. Okay. So 20 is there. So 30 is there. Next 40 is there. Next 50 is there. Next 60 is there. Next 70 is there. Like that we have. Sir, now from this I want to perform delete operation. Okay. What is the first function here is delete at first location. How to delete from the first location? I am taking the function name as delete at first. I am going to pass a self as the argument. See, what is the first step? We are going to check a condition. If self dot head is equal to none, then what is the meaning? So I can say your double linked list is empty, we can't delete, simply return the control. So if the linked list is available, then so the first operation which I am doing is self dot count is equal to self dot count minus 1. Why? Because since we are performing delete operation, definitely one element is going to be dropped from the list. That's why. Sir, as of now, from this diagram, if you write, we have how many nodes are there? Sir, 7 nodes are there. Maybe it is difficult for me to represent. So try to understand here. Sir, 4, 5, 6. Like this we have. This is a 70. This is a 60. This is a 50. So this is a 40. And this is 30. This is 20. And here one node will be there, which is nothing but a 10. Next field is this one. Previous field is this one. So this is nothing but a head pointer. And this is nothing but a tail pointer. Like that we have. Sir, initially I deleted one item. I mean, I removed the count value by 1 unit. Then, sir, it is very simple, sir. Self dot head is equal to, I am taking self dot head dot next. Suppose if self dot head is not equal to none, then so I am taking self dot head dot previous is equal to none. So that's all. This is nothing but how to delete the element. So how to delete the element present at the first location. Sir, how it is going to work? Let me take diagrammatic explanation by changing the color. Sir, here self dot count we are going to reduce by 1 unit. Self dot head is equal to self dot head dot next. What is the next node to head? 20. That will become head. Is head is not equal to none? Yes. Then we have to delete the previous link. Why? Because, sir, do you observe here? This link got deleted. Automatically this link will be deleted. Now, since head node is there, we have to remove the previous link also so that this element will be deleted. That's all. If you want, I will run this program and I will show you. Sir, from this, I want to perform list dot, so delete at first. That's all. After that, I am going to call list dot print list. Now you can able to see that element got deleted. Sir, this is the beginning list 10, 20, 30, 40, 50, 60, 70. So now 10 got deleted. We have 20, 30, 40, 50, 60, 70. Like that we have. Okay. Sir, everyone feeling comfortable about this delete at first, please confirm.
Yes, sir.
Right. Let us go for the next case here. I want to perform delete at last. How to write code for that? Very simple, sir. Here I am taking the function name as, so delete at last. What is the function name I am going to take? So delete at last, which is going to take self as the parameter. And the first constraint is the same, right? What is the first constraint? We will check. Is your head is pointing to none? If your head is pointing to none, then I am going to display double linked list is empty. Otherwise, simply return. Otherwise, what we have to do? First, try to decrement the value of count by 1 unit. Sir, after this, I am taking temp is equal to temporary node is equal to self dot tail dot previous. Sir, observe the logic I am marking in the red color. So where is the tail node? Last one, right? That will become, sir, temp is equal to self dot tail. This is the tail node 70. That previous node I am assigning it as a temp. Excellent. So that we can delete this node. How we am going to remove? Sir, temp dot next is there, right? It will become none. So this is the temp. next node, oh sorry, next node I'm going to assign as null, so that that link got breaked. Sir, next what we have to do? Sir, after that, self dot tail dot, your previous node is there, right? This is also I'm going to make it as none. So what will happen? So this particular link also got deleted. Sir, after this very important step, so now I'm taking your tail is pointing to temp and simply return the control, because the temp is 70, right? As of now, now I'm making so this one as the temp. So that means this link got automatically deleted. This is the way how to perform delete at last. Let us execute. In the place of delete first, I am taking delete last. So what output we are going to get? You can see the node 70 got deleted because that is the last element, right? So this is nothing but how you can able to perform delete at first and delete at last. So everyone feeling comfortable up to this?
Yes, sir.
Yes, sir.
Right. Now we need to perform delete at a specific location. Okay, I need to perform delete at a specific location. I will take the same list and I will demonstrate how to perform deletion from the specific location. So delete at location. Sir, how to delete at location? I am taking the function like delete at location. So self is the first parameter. We have to provide the location, which is nothing but index. We will have various cases here. What is the first case? If self dot head is equal to none, there is no elements in the linked list, your double linked list is empty, and then return the control. Otherwise, if the index value which you have given, is it less than 0, or the index value which you have given, is it greater than or equal to self dot count, that means you are giving the range value beyond the ranges. So out of range, like this we are going to get, and then return the control. Okay, so it is not empty and index is also probably available. Now I'm taking, if index is equal to 0, can I say is it something like delete at first? Yes. What we are doing, self dot count is equal to, so self dot count minus 1, then self dot head is equal to, so head dot next, and we will check. So is that head is not equal to none? Yes. Then self dot head dot, its previous field is also pointing to none. Okay, simply return the control. That's all. So already we implemented this code. It is something like delete at first. Have you observed? Self dot head is equal to self dot next. So then if head is not equal to none, its previous field we are assigning to none. Sir, this is also not satisfied. Okay, that means it is in the range, it is not empty, it is not first location. Then we are going to check, is your index is equal to self dot count minus 1. That means last, delete at last. In this case also, count is equal to, I am taking count minus 1. Then what we have to do, temp is equal to, just now we implemented that the tail is there, right? Its previous pointer we have to point. After that, your temp will become, okay, your temp dot next field will become none. I am going to delete that link. So after that, your tail is there, right? Its previous field is also, its previous field is also, I am making dummy. Then your tail node will become that temporary node and return the control. That's all. So totally 5 cases are there. What is the first case? If the element which you are giving, suppose if the linked list is empty, what will happen? That is the first case. If index is equal to 0, what will happen? That is the second case. Suppose if index is equal to last, what will happen? That is the third case. Okay. So now we have to implement, if all these cases are not satisfied, that means it is available somewhere in the middle. We have to write a big code for this to perform that delete operation. Sir, if you are clear up to this, I will write code for that. Please confirm, is it clear?
Yes, sir.
Right. Now we have to see, sir, initially I am taking index is equal to 0. Okay. Now, so temp1 is equal to, I am taking head pointer. Now observe carefully. I am taking parallelly diagram also. So I want to delete from which index, maybe index is equal to 4 I am giving. 0, 0th location, first location, second location. So third location, fourth location, fifth location, sixth location. So 1 second, sir. Please wait. Please wait for 1 minute. Please wait. Yeah, right. Sorry for the delay. Now the index which I want to delete is nothing but 4. At the fourth location, whatever element is there, we need to delete that. Sir, I have taken index is equal to initially 0 and temp is equal to head. So this is nothing but a temp1 is pointing at first node. And what about the value of I? It is nothing but 0. This is something like index, sir. Okay, right. Now I will write a loop because we have to move up to that node, right? For that is temp1 dot next is not equal to none. Okay, temp1 dot next is not equal to none, and is I value is less than index. I will take I value is less than index. Okay, so if the value of I is equal to index, what will happen? I will write code for this later. Otherwise, I'm going to take two assignments like temp2 is equal to temp1 and temp1 is equal to temp1 dot next, and then I is equal to I plus 1. These three values I am doing. Now see what will happen. Sir, first time is temp1 next field is not equal to none, 20, which is not equal to none. Is I less than index value? What is the index? 4. Yes, condition true. Is I is equal to index? No, sir. So then what will happen? Temp2 is equal to temp1. So this one will become temp2, sir. Okay. And temp1 is equal to temp1 dot next. And I is equal to I plus 1. Your I value will become 1. Since it is a while loop, again check. Is temp1 not equal to none? Yes. Temp1 next not equal to none. Is I less than index? Yes. Is I is equal to index? No. So temp2 will become temp1 and temp1 will become temp1 dot next. Is temp1 I is equal to I plus 1? Sir, is temp1 next field is not equal to none? Yes. Is I less than index? Yes. Then is I is equal to index? No. Temp2 will become, so temp1 and temp1 is pointing to temp1 dot next. Now, sir, is a temp1 I plus 1. So I will become 3. Sir, is a temp1 is not equal to none? Temp1 dot next field? Yes. Is I less than n? Yes. I less than index? Yes. Is I is equal to index? No. Now this will become temp2 and this will become temp1. Have you observed which node we need to delete? We came to that position. Now we have to delete this. Let me run one more time. Is temp1 dot next is not equal to none? Yes. Okay. Then is I is less than n? Your I value will become 4, right? Is I is less than n? No, right? But it should not stop. I think it has to move. Because when I is equal to 4, better to take here less than or equal to index or index minus 1 like this. If you take, okay, let us see index less than or equal to index. Yes, the condition is true. Is I is equal to index? Yes. Here we have to write a code to delete. Sir, we came up to the position where we need to delete. We came to the up to the position where we need to delete. Now you can able to see. So where temp1 and temp2 are available. Sir, where temp2 is available, which is pointing to 40th node. Okay. So where temp1 is available, which is pointing to 50th node. Sir, which node we have to delete now? 50, right? So now we have to write code for that in this particular place of pass. If you are clear up to this, I will write code for this. Is it clear up to this, whatever I covered, friends? Please confirm. Yes, please respond. Clear up to this. Right. Now you can see what code we are going to write here. Sir, very simple. I am going to take, so temp1 dot next is equal to temp1 dot next. Now observe this point. So where temp1 is pointing? Sir, is it 50 or not? Temp1 dot next field will become, so temp1 dot next. So I think it is deleting 5, sir. Okay, no problem. You can change it later, but analysis is same. Now it is deleting which node? 5th location. So temp1 is temp1 dot next. This field is pointing to temp1 dot next. So it is pointing here. Okay, sir, next after that, what is the next step? Your temp2 will become temp1 dot next. As of now, temp2 is pointing this one. Now this will be changed to temp1 dot next. This means this is nothing but temp2. Now, what is the next instruction? Sir, if temp2 is not equal to none, yes, temp2 is not equal to none, then your temp2 previous field is pointing to temp1. This is temp2, its previous field is pointing to temp1. Okay, sir, after doing this, we have to reduce the count by 1 unit. So self dot count is equal to, I am taking self dot count minus 1. That's all. Immediately you can return the control. That's all. This is the way how to delete one element from the list, sir. Okay, so I think the code is very clear for you. But let me run the program, then only we will get clarity. Sir, I am taking delete at a location. We have to pass how many parameters? Only one parameter, which is nothing but the location. Suppose consider I am giving 0. So it is going to delete the element which is present at 0th location. Is it deleting 10? Yes. Now I will change this location to 1. Let me cross check. Is it deleting the element at first location? No, it is not deleting. You can see 10 is there, 20 is there. It is deleting 30. That means something is wrong. Better to start I value from the 1. Okay. We are going to count from 1. Then is it going to delete 20? Yes. Now I am giving the location value as a 2. It has to delete the element present at second location. So 30 is deleted. Now I am giving 3. Sir, now let me cross check. Is 40 got deleted? Yes. So now I am giving 4. Sir, now cross check. Is 50 got deleted? Yes. Sir, now I am giving 5. Now see what will happen. Sir, is that 60 got deleted? Yes. Now I am giving 6. Now see, sir, is that 70 got deleted? Yes. Now I am giving 7. Sir, what will happen? Out of range. So like that, we can perform which operation? Delete at a specific location. Sir, everyone feeling comfortable up to this, whatever we covered? Please confirm. Sir, is the concept is clear, friends? Please confirm. Right. Sir, next operation is very simple operation. I'm going to take a search operation. Search. I want to search for an element. How to implement that? We need to take the data field which you want to search. So I will take a temporary node is equal to self.head first node, and I am going to check until that node is not equal to none. I will keep on checking the content. If temp.data is equal to the data which you have given, then I will return true saying the element is available. Else what will happen? Your temp will become temp.next. And at last we are going to return false saying that element is not available. That's all. Let us implement here. Sir, we have list is there, right? So I want to call list dot. I want to search for the element. Which element I want to search? Let us take 40. So now I want to search for the element called 41. Sir, 40 is available, 41 is not available. So 40 is returning true. For 41, it is returning false. So like this, we can able to check whether the element is existed in the list or not. Sir, everyone feeling comfortable up to this, whatever we covered? Please confirm. Clear? Sir, need response from everyone. Please confirm. Right. This is nothing but double linked list what we have. Okay. So if you want that copy operation, reverse list, so whatever we covered in the single linked list, based on that you can. Okay. And so by seeing your response, so single linked list got completed, double linked list got completed. This circular single linked list and a circular double linked list. So I will cover on coming Sunday session, sir, because I know you people are struggling for learning this. So I'm going to stop today's session and I want to continue this linked list in the next class, that is tomorrow. So I will take this class on coming Sunday. The people who are interested, you can join on that session, and the remaining people try to watch. Totally 3 sessions we had a discussion on linked list. Try to watch these 3 videos, and at least the last chance I'm giving so to practice that. Okay, so tomorrow we will start a stack data structure. Okay, and we will start a queue data structure also. So stack and queue data structures will be covered in the tomorrow's session, tomorrow and the day after tomorrow. And before that, so that sorting and searching algorithms summary is there, right? I will cover tomorrow about that one also. So after that, I will take this stack and queue data structures. Okay, so after that, in this week itself, we will finish this bit manipulation, like how to work with the binary numbers. Okay, so after that, I am going to cover the remaining topics. So next week plan is we are going to see this. So summary sheet tomorrow, and stack data structure, queue data structure, bit manipulations. Okay, so after that, linked list. Coming week plan is nothing but this one. Okay, right, sir. I will upload the running notes within few minutes. You can cross check. Thank you. You can leave the session now. Thank you, guys.
Sir, tomorrow at what time?
Same, sir. Same. Only Saturday and Sunday at 6 o'clock it will be there. Remaining days as usual 7 o'clock only.
Okay.
Thank you.